7 motorcycle engines changed everything we know about two-wheeled performance. Some topped 200 miles per hour. Others rewrote the rule book on reliability. And one literally invented the superbike category overnight. But here's the twist. The fastest wasn't the most influential. And the oldest on this list still shapes every BMW you can buy today. Number 7. Kawasaki H2 Mach IV, 1972. Let's start with the wildest engine to ever grace a production motorcycle. The Kawasaki H2 Mach IV's 748cc two-stroke triple. In 1972, this beast produced 74 horsepower in a bike weighing 452 pounds wet, running a quarter mile in just over 12 seconds when most bikes struggle to crack 13. Honda and the Japanese manufacturers had gone 4-stroke, and Kawasaki needed to compete without spending Honda money on complex designs. Their solution? 3 cylinders, 2-stroke configuration, and enough raw thrust to make grown men reconsider their life choices. The H2 used a separate oil injection system called Super Lube that varied based on throttle position and RPM. Sophisticated for its time, but the delivery pump failed without warning, leading to seized pistons. The H2 earned nicknames like Widowmaker from emergency rooms, not marketing departments. Power delivery was viciously peaky, almost nothing below $4,000, then a savage hit at 6,000 RPM that could swap ends on you. The frame was undersized, brakes marginal, and handling got exciting in ways insurance companies frown upon. Why it belongs here. The H2 proved you didn't need a massive 4-stroke to get stupid fast. Every modern sports bike's obsession with power-to-weight ratios traces back to Kawasaki's willingness to build something physics suggested they shouldn't. Modified H2s dominated drag racing throughout the 70s. If you're buying one, the Super Lube pump is your enemy. Budget for a complete rebuild or pre-mix conversion. Number 6. Harley-Davidson Knucklehead, 1936. How did a Harley engine make a list about innovation? The Knucklehead OHV twin-turbo genuinely transformed American motorcycling, but understanding why requires looking at what came before. In the early 30s, Harley-Davidson was getting schooled by Indian motorcycles. Harley's flathead V-twin engines were reliable, but couldn't make competitive power, while Indians' overhead valve designs were faster and smoother. The Knucklehead arrived in 1936 with 61 cubic inches, roughly 1,000 cc, and overhead valves controlled by push rods. It made 40 horsepower, nearly double what the old flatheads produced, establishing the visual and mechanical DNA that would define Harley-Davidson for the next century. The nickname came from riders who thought the rocker boxes looked like knuckles. Harley initially hated it. They wanted OHV, but the name stuck. The innovation wasn't just overhead valves. Engineer William Harley designed a recirculating oil system that was light years ahead of the total loss systems common then. Previous Harleys literally dumped their oil on the ground. The Knucklehead kept its oil internal, meaning you could ride more than 50 miles without stopping to add oil. But these engines leaked like a screen door on a submarine. Harley didn't truly solve oil leak problems until around 2005. In 1937, a Knucklehead hit 136 miles per hour at Daytona Beach, legitimizing Harley as a performance brand beyond police bikes. Those overhead valves need checking every 1,000 miles. Budget, a solid afternoon for tune-ups. Number 5. BMW R32 Boxer, 1923. Here's an engine older than your grandfather that still defines an entire brand. The BMW's R32's 494cc flat-twin Boxer from 1923 is arguably the most influential motorcycle engine ever built when you measure impact over time. After World War I, Germany's economy was shattered, and BMW had been building aircraft engines. The Treaty of Versailles ended that, so they needed a new product fast. The motorcycle market was wide open, but filled with crude, unreliable machines that broke constantly and vibrated riders' feelings loose. BMW engineer Max Friz looked at 1923 motorcycles and thought they were doing everything wrong. His innovation was simple, but fundamentally radical. Mount the cylinders horizontally, sticking out into the airstream for maximum cooling, and configure them as opposed twins to naturally balance vibration. Then connect the transmission directly to the engine and drive the rear wheel with a shaft instead of chains or belts. The result was like dropping a machine from the future into 1923. The Boxer engine was smooth and air-cooled evenly. The shaft drive meant no chain maintenance. You just rode. For riders used to adjusting chains every few hundred miles, this was witchcraft. That basic layout from 1923, longitudinal Boxer engine, shaft drive, full cradle frame, is virtually identical to what BMW still builds today. A rider from 1923 could look at a modern R18 and immediately understand it. That's 102 years of continuous design evolution from a single blueprint. Number 4. Ducati Desmodromic L-Twin. Let's talk about Fabio Taglioni, because you can't discuss Ducati without the man who gave the company its mechanical soul. In the late 50s and throughout the 60s, Taglioni was obsessed with valve float. Valve springs simply couldn't close valves fast enough, limiting engine speed and therefore power. Taglioni's solution was Desmodromic valve actuation, a system using mechanical cams to both open and close valves, eliminating springs entirely. Mercedes-Benz had tried it in racing cars, and other engineers experimented with it, but Taglioni made it work reliably on a motorcycle. First with singles, then with the iconic 90-degree L-Twin. The first proper Desmo L-Twin appeared in 1971 with the 750 GT, but the 1972 750 Imola racer validated the concept. Ducati entered that race as complete underdogs against the dominant Japanese inline fours. Nobody expected the Italian V-twin to compete, but Paul Smart and Bruno Spaghieri took first and second place, thoroughly embarrassing Honda, Kawasaki, and everyone else. Why did it work? The Desmodromic system allowed Ducati to run higher valve lift and more aggressive cam profiles without worrying about spring rates or valve flow. The engine breathed better at high RPM and made about 80 horsepower from just 748 cc, competitive with Japanese 750s using 4 cylinders. But here's the controversy. Ducati fans called Desmodromic valves engineering perfection. Ducati mechanics call them a maintenance nightmare. Both are correct. The system requires incredibly precise clearance adjustment on multiple points per valve. Mess it up, and you can destroy an engine faster than you can say, expensive Italian paperweight. The L-Twin configuration was also brilliant. The 90-degree angle provides perfect primary balance, and mounting it longitudinally creates a low center of gravity and ideal weight distribution. Plus, it looks fantastic. Every Ducati superbike since 1972 uses this basic configuration. The 916, the 999, the Panigale, all Desmo L-Twins. Number 3. Kawasaki Z1 900, 1972. Now we get to the bike that made Honda's engineers spit out their coffee. The Kawasaki Z1 900 and its 903cc DOHC inline 4. If the CB750 invented a superbike, the Z1 perfected it and established Kawasaki as the performance king. The backstory is wild. Kawasaki had actually developed a 750cc 4-cylinder bike before Honda's CB750, ready to release in 1968. Then, Honda dropped the CB750 bomb. Kawasaki's management made the ballsiest decision in motorcycle history. They shelved their 750, went back to the drawing board, and decided to build something so much bigger and more powerful that Honda couldn't respond quickly. The Z1 that emerged in 1972 wasn't an evolution. It was a declaration of war. The 903cc DOHC inline 4 made 82 horsepower, nearly 20 more than the CB750. It would run a quarter mile in 12.0 seconds flat and top out at 132 miles per hour. In 1972, that made it the fastest production motorcycle in the world. The Z1's engine was over-engineered in the best way. Kawasaki used a chain to drive the double overhead cams. Honda used a single cam. which meant they could use more aggressive cam profiles. They used plain bearings for the crankshaft instead of roller bearings, making the engine smoother and more durable at high RPM. Kawasaki deliberately overbuilt the bottom end, meaning it could handle significantly more power than stock. Guys were making 150 horsepower with these engines and having them survive. Number 2. Honda CB754, 1969. Here's the big one, the engine that actually created the modern motorcycle industry. The Honda CB750's 736cc SOHC inline-4 didn't just transform motorcycling. It effectively ended the British motorcycle industry and established Japanese engineering dominance for the next 50 years. Let's set the scene. It's 1968, and motorcycles are still basically 19th century technology. British bikes leak oil, vibrate, and break down regularly. American V-twins are better, but still crude. The entire industry stuck. Soichiro Honda asked a simple question: why can't motorcycles be as reliable as our cars? Honda had been building automobiles for years and knew how to make engines that started every time and ran 100,000 miles without major service. The CB754 arrived in 1969 like aliens had landed. A 736cc transverse inline-4 making 67 horsepower, overhead cam, electric start, front disc brake, an absolute first for production motorcycles, 5-speed transmission, and an engine so smooth it made British twins feel like industrial equipment. But here's what really mattered. It worked. You turned the key, pressed a button, and it started every time, in any weather. In 1969, that was revolutionary. British bike owners were used to kickstarting their machines 20 times on cold mornings. The disc brake deserves special mention. Every other production motorcycle in 1969 used drum brakes. The CB750's hydraulic disc brake was borrowed from Honda's automotive division, providing stop and power British manufacturers couldn't match. Dick Mann won the Daytona 200 in 1970 on a CB750, legitimizing the 4-stroke format and basically writing the obituary for British motorcycles. Quick pause here. If you're getting value from this video, hit that like button. It genuinely helps other writers find this content. I read every comment too, so if you think I got something wrong or you got a story about wrenching on one of these engines, drop it below. Number 1. Suzuki Hayabusa GSX 1300R, 1999. And here we are at number 1. The Suzuki Hayabusa's 1299cc inline-4. How is a 1999 engine more influential than the CB750 or the BMW R32? The Hayabusas didn't just break records. It broke the entire gentleman's agreement between motorcycle manufacturers and forced governments worldwide to reconsider what they'd allow on public roads. By the late 90s, the Japanese manufacturers had gotten comfortable. Superbikes were making 160 horsepower and topping out around 175 miles per hour. Meanwhile, European manufacturers like Ducati and BMW were claiming performance superiority. Suzuki needed something dramatic. What they built was genuinely shocking. The 1299cc inline-4 made 173 horsepower and would run a quarter mile in the high 9s. But the real story was the top speed, 194 miles per hour. Verified. This wasn't a limited production exotic. This was a regular production motorcycle you could buy at any Suzuki dealer for $10,000. Suzuki used a unique crankshaft design with gear-driven counterbalancers that made the big inline-4 surprisingly smooth. They developed fairings in a wind tunnel used for aircraft design, creating bodywork so dynamic that riders reported feeling like they were sitting in a bubble at high speed. Here's the controversial part. The Hayabusa was so fast that it triggered a panic. European governments threatened to ban high-performance motorcycles entirely. In response, manufacturers agreed to a voluntary limit of 186 miles per hour for all production bikes. That agreement holds to this day. The Hayabusa literally forced the industry to set speed limits on itself. So there you have it, 7 engines that fundamentally transformed motorcycling, from BMW's Boxer that invented the modern touring bike to Suzuki's Hayabusa that went so fast it forced international speed agreements. These power plants didn't just push boundaries, they redrew the map entirely. The common thread? Each solved a real problem with an approach that seemed crazy till it worked. Kawasaki built a 2-stroke triple that physics said should shake itself apart. Ducati eliminated valve springs when everyone else said they were essential. Honda made motorcycles reliable when the entire industry accepted that bikes were supposed to leak and break. If you're serious about understanding motorcycle engineering, subscribe to this channel. I'm promising detailed, researched content about the machines we actually care about, the engineering, the history, the controversies manufacturers don't advertise. Drop a comment telling me which engine you'd most want to own, or which one I ranked wrong. I love the debate. Ride safe, wrench smart, and I'll see you in the next one.